Hello students, in this video we are discussing Cbse class 9 science NCERT textbook chapter 8 motion, so which comes under physics. Okay, so we've already discussed few topics in this chapter. We've almost completed up till the concept of acceleration. Today we'll give a quick recap of what we saw in the previous video, and then we'll do some numericals related to the concept of acceleration. So what is acceleration? Rate of change of velocity. So we learned what is rate. Rate is nothing but it means that is something which is going to change, and it is going to be a ratio. And generally the quantity for comparison is usually time. And here also when you compare change of velocity, we are going to compare it with time. So that is what we are going to see here. Acceleration is a measure of the change in velocity of an object per unit time. So here you can see acceleration keeps on changing with respect to the velocity. So acceleration is like the same. It's like 1 meter per second together. It remains the same throughout, but velocity keeps on increasing at the rate of 1 meter per second for every 1 second. At the rate of 1 meter per second for every 1 second. Finally, it came to a stop when there was an obstacle on this side. So here we saw again we just seeing the same thing, change of velocity per time, and we also saw that for this we were able to find out the unit to be meter per second square. The unit for acceleration was meter per second square because change of velocity. So for velocity it is going to be meter per second. For time you have another second, so you will have meter per second square to be the SI unit. Next we saw about uniform and non-uniform motion. So uniform motion means what? There is no change in the velocity. So the change in velocity is going to be 0. Change in velocity is going to be 0. So 0 by t will be 0. That is why acceleration is 0. If there is uniform motion means the acceleration is not at all there, okay, because it is going to move with the same speed. Non-uniform motion means what? The velocity is going to continuously change with respect to time. So change in velocity will not be 0. If this is not 0, then you will have a value for change in velocity. So which will be final velocity minus initial velocity. Generally we take the final velocity to be v and the initial velocity to be u. So change in velocity will be what? V minus u. And so acceleration will be change in velocity by time taken. So it will be v minus u by t, which will be equal to a. So this is the formula for acceleration. So the unit is meter per second square. You can write it either like this or ms power minus 2. Next we are learning about positive and negative acceleration, because acceleration in all the cases does not necessarily mean it should be speeding up. It can be either speeding up or it can also be slowing down. Okay, you can either slow down or you can speed up. So if you are going to speed up, you are going to say it is going to be acceleration. If you are going to slow down, you are going to call it to be deceleration. It is going to be deceleration, or you can call it to be negative acceleration. Negative acceleration. So when you are going to talk about acceleration or speeding up, then it means what? Initial velocity was less, so the final velocity is more than the initial velocity. Here it is just the opposite, that is the final velocity is less than the initial velocity. You also call this deceleration to be retardation. Is also called as retardation. You have some keywords to remember when you look into the numericals. So when you say you're going to speed up, or when you say an object starts from rest, then your u will be 0. Starts from rest means what will be 0? U will be 0. Okay. When you say that the brakes are applied, and an object goes to rest, then v will be 0. Remember what will be lesser? V will be lesser. So what will be 0? V will be 0 when it is retardation. So when it is acceleration, your v can never be 0, only u can be 0. So uniform acceleration will happen when an object travels in a straight line and the velocity changes by an equal amount in equal intervals of time. What about non-uniform? The velocity will change at a non-uniform rate. Then you say that it is a non-uniform acceleration. So once again, we'll quickly recap the formula which we've learned. So speed is equal distance by time taken. So compare this with velocity. Velocity is displacement by time. Likewise, average speed is what? Total distance traveled by total time taken. But average velocity for non-uniform motion will be similar to this. For non-uniform motion only. So which will be displacement by time taken. But what about uniform motion? It is initial velocity plus final velocity by 2. That is u plus v by 2. Now we have learnt a new formula for acceleration. Change in velocity by time taken. Change in velocity by time taken is what? V minus u by t. So A is equal to V minus u by t is a new formula which you have learnt now. So we'll get into the next numerical, or we have already seen 4 numericals altogether under speed and velocity, that is speed, average speed, distance, displacement, velocity, average velocity and all this. Now we are going to see a fifth question here. Look at the question very carefully. A train accelerates from 36 km per hour to 54 km per hour in 10 seconds. What did I tell you in the previous video? Whenever you look at any problem, like any numerical, first you will have to go in for the units. Please be careful with this. Okay, units are very important. If you are going to make some mistake here, if you are going to miss out on these, so units are very important. If you are going to make some mistake by not checking on the units, there are major chances that you may go wrong when you are going to do the final answer. Okay, so please be careful with the units. Okay, so units are very important. So now here what they've given, from 36 kilometer per hour. So that means 36 kilometer per hour is your initial velocity. 2, this is your final velocity. And this is your time. Look at the units. Here it is given in terms of kilometer per hour, and here it is given in terms of seconds. What did I tell you? It is always better to convert it in terms of meter per second or in terms of seconds. So here kilometer per hour has to be converted. So I told you, when you're going to convert 36 kilometer per hour in terms of meter per second, you can multiply it by 5 by 18, or you can do it like this, 36 into 1000 by 3600. Okay, so in that case you will have 0 getting cancelled, 36 and 36 will get cancelled, you are left with 10. 54, 0 will get cancelled, so 36 you just see if it will go, 6 are 36, 6 nines are 54, again 3 twos are 6, 3 threes are 9. So 2 fives are 10. So you will have 5 threes are 15 meter per second. Now check for the units, all the units are similar. So directly what you have to find? Acceleration. So what is the formula of acceleration? V minus u by t. What is my V? 15. What is my u? 10. So what is my t? 10. So my answer is 5 by 10, which is going to be 0.5 meter per second square. Okay, so this is the answer for this question. Let's look at the next question. A truck traveling at 54 km per hour is slowing down. That means what? Here we are talking about deceleration or negative acceleration or retardation. Okay, so retardation. They are asking us to find out the retardation. You should be very careful while writing the answer. If you're writing in terms of retardation, you should write the answer only in positive. Or if you're going to write it in terms of deceleration, you're going to write the answer in positive. But if you're going to give the answer in acceleration, you will give the answer in negative, because it is negative acceleration. Otherwise, if you look at the previous and this problem, it is the same. The values are all the same. See, same kilometer per hour is given. Okay, so you'll have to convert it. You are getting 15 and 10. But remember, here this is my u and this is my v. So what will be v minus u by t? It will be 10 minus 15 by 10. So which will be minus 5 by 10, which will be minus 0.5 meter per second square. So we've got it here. Okay. So if you're going to write the answer as acceleration, you have to mention the negative sign. But if you're mentioning it as retardation, you have to mention it as positive only. Why I'm stressing this is because you will get these kind of confusions when you are doing the multiple choice questions. Because when they are going to ask you to find the retardation in the MCQ and they're going to give you the option, they'll be giving you the option with plus and minus. So you should only be careful to choose what you have to find out correctly. So look at this question. A train is starting from rest. So they have told that the train is going to start from rest. That means your u is 0. And then it is going to accelerate uniformly at the rate of 5 meter per second square. So you should be very careful. Don't immediately jump to the conclusion that it is going to be v. It is not v. See, it is accelerating at the rate of this much for 5 seconds. So this is going to be my t, but this is my acceleration a. Okay, so we are given u, we are given a, we are given t. Remember that. Calculate the velocity of the train in 5 seconds. So here they are asking us the final velocity v. Okay, so they want us to find the final velocity v. So I know a is equal to v minus u by t. My a is 5, my v is unknown, my u is 0, my t is 5. See, because the units are all similar, I'm not going to make any changes. So my v will be what? 5 into 5. So my v will be 25 meter per second. So it's very simple. Okay, you should know what is given. Don't immediately jump into conclusions by not reading the question carefully. We look at the next question. An object dropped from a cliff falls with a constant acceleration of 10 meter per second square. Okay, it is going to fall down with a constant acceleration. Okay, here constant acceleration, but still we are taking it to be plus. Okay, we are not taking it to be minus. Okay, even if we say it is going to fall, okay, we'll know the main reason behind this when we learn the next few chapters. You'll be able to understand this. Find the speed 5 seconds after it was dropped. So this is my t, this is my a, but they have given one hidden data is an object is dropped. See, this is a keyword. Whenever you have the word gently dropped or falls on its own, you should know that the initial velocity is 0. That means we are not throwing it with a big force. For example, if I am going to keep an object here, even without giving any push, it can automatically fall down, right? So that is gently dropped. So there is no external velocity given here. It automatically fell down because of the Earth's gravitational pull. Okay, so it is moving along the gravitational force. That is why even A is taken as positive. Okay, A is plus 10 meter per second square. Time is 5 seconds. Look for the units. Yes, the units are all similar. Otherwise, it is similar to the previous question only. Because even here, U, A and T are given. And they are asking us to find the final velocity V. So, my A is what? 10. What is my V? Is unknown. U is 0. T is 5. So, what will be V? 10 into 5. So, V will be 50 meter per second. Got it? So this is how you will have to approach a numerical. So even in your textbook you have the NCERT exercises 1, 2, 3 and 4 and in-text questions in page number 102 and 103 similar to this. So as soon as you listen to this video, I want you to try working out all these questions so that it will be easy for you to understand. So with this we have completed nearly half of the lesson. Okay, and nearly half of the lesson is completed. Okay, so half is completed and we'll be proceeding with the next video by learning about the graphical representation of motion. Learning about the graphical representation of motion. So it is just going to be the next half of the chapter. So I hope you all have understood the first part of the lesson. If you have understood the concepts which we learned there regarding speed, velocity, acceleration, and then regarding uniform, non-uniform motion and all, it will be easy for you to understand this graphical representation concept also. So see you again in the with the next part number 7 in the new video, children. Thank you, children.